Good morning to all. Is it audible?
Good morning, sir. It's audible, sir.
Okay. Is it visible my screen? Screen కనపడుతుందా అండి? సిఆర్ హారిక
No, sir.
ఓకే. Good morning to all. Is it audible? Okay. Okay, so what is the last topic? So session start చేయొచ్చా వెయిట్ చేద్దామా సిఆర్?
Start చేద్దాం, sir.
ఓకే, సో ఎవరికైనా లింక్ లేకపోతే యూట్యూబ్ లింక్ ఇక్కడ అలా షేర్ చేశానంటే మీ గ్రూప్లో పెట్టేసేయండి, లేదా నేను క్లాస్ రూమ్లో పెట్టేస్తాను, గూగుల్ క్లాస్లో.
Okay, sir.
ఏమో 122 టర్న్. మై గాడ్. సో ఏం డౌట్స్ ఉన్నాయండి సిఆర్ లాస్ట్ క్లాస్లో?
No, sir.
లేదు. మై గాడ్. నో డౌట్స్. ఓకే, నేను హోంవర్క్ ఇచ్చానా లాస్ట్ క్లాస్లో? ఇచ్చాను, ఇవ్వలేదా?
ఇచ్చారు, sir.
ఓకే, ఎంతమంది సాల్వ్ చేశారు? ఓకే, సర్లే. So now I will give the first of all brief review of the previous session. I think in the previous session, so we have seen curl of a vector point function. So curl of a vector point function. So symbolically we will write here the del cross f. We will write it is the del cross f. Here f is the vector field and del is the del operator. That means I dou x by dou by dou x plus j dou by dou y plus k dou by dou z. And the curl of vector f is just it is the determinant of 3 by 3 matrix. In the first row is ijk, second row is dou by dou x, dou by dou y and dou by dou z, and third row is f1, f2, f3. Here f1, f2, f3 related to the vector point function f. Okay, and after simplification we will get the determinant of this matrix is I into dou f3 by dou y minus dou f2 by dou z minus j into dou f3 by dou x minus dou f1 by dou z plus k into dou f2 by dou x minus dou f1 by dou y. So this is the calculation of the curl of a vector point function f, and we have seen some problems. ఒక్క నిమిషం ఎవరన్నా 101. ఓకే, ఎక్కడున్నా? ఓకే, so first problem is the f is the vector point function x square y I minus 2x z j plus 2y z minus k. The question is here, find the curl f or the del cross f. Both are same meaning, so just find the determinant of the matrix. So the first row is ijk, second row is dou by dou x and dou by dou y, dou by dou z, and third row is the vector, that means x square y minus 2xz and 2y. After finding the determinant of the matrix, okay, it is the dou. So after differentiating with respect to so after differentiating with respect to y, this part is only 2z, and after differentiating with respect to x, so z, it is will get the minus 2x, but already here, so plus 2x, so it is the first part. Similarly minus j into, so derivative of this part 0 and derivative of this part with respect to z 0. Next one k into, so k into, so after differentiating with respect to x, it is minus 2z, and after differentiating with respect to y, it is the minus x square. So the final result is 2 into x plus z I minus of 2z plus x square k is the curl of the given vector f. So it is the first problem, and the second problem is so the second problem is the curl of vector v. So v is here 2x square I plus 3z square j plus y cube k, and just find the determinant of the this 3 by 3 matrix. First row is we know that ijk, second row is dou by dou x, dou by dou y, dou by dou z, and the vector is here 2x square and 3z square and y cube. After simplification we will get the result I into 3y square minus 6z is the curl of the given vector. But the second question is same question, but curl of the vector we want to solve at the point 1, 1, 1. Already we know that the curl of vector is I of 3y square minus 6z. Now substitute x, y, z values are 1, 1, 1. Now we will get the final result is minus 3I is the curl of vector at the point 1, 1, 1. So answer is minus 3. It is the third problem. And what is the fourth problem? The fourth problem is just it is given that a vector point function lambda x plus y plus lambda I plus j minus x plus y into k, where lambda is the constant, and here it has given some equation vector f dot the del cross f is 0, just to find the unknown. So for that, first of all find the del cross f. The del cross f, the result is minus I plus j minus k, and the dot product of f and curl f is, finally here we will get the 1 plus x into minus lambda plus 1. But anyway here the 1 plus x is the non-zero because it is related to variable. So minus lambda plus 1 must be 0. That means lambda 1. If the lambda is 1, so this f dot curl f must be 0. Otherwise it is the non-zero. So our answer is C. That means 1 is the answer. Okay, it is the fourth problem in the previous class. Next one, fifth problem. F is the vector. So sorry, if f is not a vector, it is the scalar point function. Scalar point function, and the del is the operator. We know that I dou by dou x plus j dou by dou y plus k dou by dou z. And the first question is del dot del f. So del dot del f means, what about this mean? So same problem we will write like this also, del dot del f. How can we write? Same problem. So same problem we can write div of gradient of f, both are same. Okay, because f is here the scalar point function, f is the scalar point function, del f means it is the gradient f, and the second one is the del dot del f, that means divergence of gradient of f. So we call it is the divergence of gradient of f. So this is our question. So divergence of gradient of f is, so first of all we have to find the gradient f, that means del f. So del f we will get I into I. So I into 2xy plus z square plus j into 2yz plus x square plus k into 2zx plus y square, and the divergent of this vector is, again just you have to do the dot product of the two vectors. Then we will get the 2y plus 2z plus 2x. It is x, not z. It is x, sorry, there is a mistake. It is the 2x. Okay, now at the point 1, 1, 1, the result is 6. So the result 6. Next one, I think I have given homework to you. So this is the sixth problem, homework. How many have you done? How many have you done? ఎంతమంది సాల్వ్ చేశారండి? ఆన్సర్ వచ్చిందా?
Yes sir.
6 వచ్చింది ఆన్సర్?
వచ్చింది sir.
Okay. So in this one we have we will write a formula. The formula is del dot del cross del f always 0. That means the divergent of curl of gradient of f always 0. So this is the one of the statement. The divergent of curl of gradient of f always 0. Okay. Now the next one, I think I have given homework to you. So 2 problems. The first problem is just find the del dot f and del cross f. That means divergent of f. Here the question is divergent of a and curl of f. ఎంతమంది క్వశ్చన్ రిజల్ట్స్ చెప్తారు ఎవరైనా రిజల్ట్స్? వాట్ ఈస్ ద ఫస్ట్ రిజల్ట్? సాల్వ్ చేశారా లేదా? సియా రిజల్ట్స్ వచ్చాయా రాలేదా?
వచ్చాయి సార్. సార్ డైవర్జెన్స్ ఆఫ్ f I plus 2j plus 6k.
కొంచెం మెల్లిగా చెప్పండి, నేను నోట్ చేస్తాను. చెప్పండి.
I plus
the first result is I plus
2j.
I plus 2j వచ్చిందా?
Yes sir.
At the point triple 1 minus 1 1 divergent. ఇక్కడ వెక్టర్ రాదండి, ఇది స్కేలర్ అండి.
ఓకే సార్.
ఇది స్కేలర్. స్కేలర్ వాల్యూ ఏమొస్తుందంటే నేను రాస్తానండి. The scalar value here 9 is the value, because del is the del operator and here f is the vector point function. So vector point function means the dot product of the these two vectors must be the a scalar. Next వచ్చేది
yes sir 9 sir.
ఓకే 9 వచ్చింది. సెకండ్ ఆన్సర్ ఏమొచ్చిందండి కొంచెం వెరిఫై చేసుకోండి మీరు. సెకండ్ రిజల్ట్ మైనస్ I minus 2k వస్తుందేమో వచ్చింది ఇది.
yes sir. వచ్చింది sir.
So this is the second result. Next come to the next problem. దీనికి the gradient of, that means gradient f or del f, both are same meaning. ఏమొచ్చిందండి 3x square minus 3yz I plus 3y square minus 3xz, just y missing. Next one 3z square minus 3xyk. This is the del f. Next result ఏమొచ్చిందండి? Now it is the scalar. Del dot gradient of f, definitely it is the scalar. The scalar result is 6x plus 6y plus z. ఇది వచ్చిందా? రాలేదు.
వచ్చింది సార్.
Next third result is 0. So 0, that means this gradient f, it is the this gradient f, this f is the now irrotational vector. Irrotational vector. Okay. So this is the about the previous homework. Next one income. Oh my god. Okay, now the next one is the irrotational vector. So what is the definition of the irrotational vector? If the curl f or the del cross f0, that we call as the irrotational vector. So this is the example of the irrotational vector, one of the example. Next one, the necessary and sufficient condition for the irrotational vector. What is definitely, if suppose the vector is f1y plus f2j plus f3k, if it is irrotational vector, definitely dou f3 by dou y must be equal dou f2 by dou z, and dou f3 by dou x must be equal dou f1 by dou z, and dou f2 by dou x must be dou f1 by dou y. So definitely it must be satisfied. This is the necessary and sufficient condition for the irrotational vector. Okay, and now the some problems. So this the given vector is the irrotational vector because the curl of this f must be 0. because we will get the I into x minus j into y minus k, y minus y, and k into z minus j. So finally the conclusion is here, this vector, it is in the form of yzi, x missing, next one xzj, y missing, xyk, z missing. So this type of vector always it must be irrotational vector. Irrotational vector, that is the observation of this problem. Next one, come to the second problem. So second problem, it is given that a vector, and clearly it is given that irrotational vector, and just find the unknowns. So find the unknowns means just first of all assume the determinant of this matrix must be 0. So after comparison we will get the c plus 1 0 and 4 minus a 0 and b minus 2 is equal to 0. That means a is equal, will get the 4 and b is equal to 2 and c is equal to minus 1. Okay, that means if a is equal to 4, b is equal to 2 and c is equal to minus 1, the given vector is irrotational vector, otherwise it is not irrotational vector. Next one, I think I have given homework problems to you. So f is a vector point function, just to show that this is the irrotational vector. So irrotational vector means we have to show that curl f must be 0, or del cross f, you have to prove that 0. Okay, first solve this and first problem.
Yes, sir.
Okay, good. Next one, come to the second problem. So second problem is the same, but in the second problem I have given one more question. Show that irrotational vector and also prove that solenoid. That means in this one you have to prove that this del cross f must be 0, that is related to the irrotational vector, and del dot f must be 0. So for this problem it is must be satisfied these two conditions. That means the given vector is the both irrotational vector as well as solenoid. Okay, next one, come to the third one. So third one, just prove that irrotational vector. So irrotational vector means just to find the del cross f, just show that del cross f is 0. Okay, next one, fourth one also same, and the small correction in the last class I have given a is equal to 3 and b is equal to 2 and c is equal to I think 1. Okay, but in this problem for all a, b, c, this vector is the irrotational vector, that is a small correction. Okay, Nandi, that is a small correction. Next one, so I am given additional 6 more problems. So here this type of vector always irrotational vector. Okay, so here the pi 1 is and pi 2 and pi 3 are, pi 1 is function of x and pi 2 is function of y and pi 3 is the function of z, and ly and here lx, because after calculating the dou m by dou y and dou n by dou x, this is same equal. Similarly same here, the coefficient of z here and the coefficient of x same, and the coefficient of z and the coefficient of y same. This must be the, this type of structure always it must be gives the irrotational vector. Like that we can generate many vectors. Okay, so here okay example istava according to the fifth statement. See here, x square and the coefficient of L, suppose I am taking the 2, and the coefficient of m is I am take I, j and k. So function of y, suppose I am taking y cube as function of z here, anything, and observe here the 2y. So 2y means, so definitely in the second one we will get the 2x. Next one, suppose here I am taking 5z, that means it is related to x. So in the z, if it has the 5x. Next one, come to the second part. In the second part, suppose here I am taking, suppose minus 3z, here minus 3y. So definitely this vector must be irrotational vector. Clear, Andy? Like that we can generate the many irrotation vectors. Okay? Am I clear? Or you get my point?
Yes, sir.
Next one, come to the sixth vector point function. So function of x plus y z I, function of y x z, and function of z plus xy. It is always irrotation vector. So this type of vector also gives always irrotation. So here also we can generate many vectors. So x square and yz plus xz minus 3y square j plus xy plus e power z. So this one also always a irrotational vector. Like that we can generate the many irrotation vectors. Okay? So from the fifth and sixth one we can easily generate many irrotational vectors. Next one, come to the seventh one. So it is the both combination of the So observe here it is the linear. So according to the fifth question, we will generate the here a irrotational vector. Irrotational vector. Now, so observe here the coefficient of y here a, and the come to here the coefficient of x. The coefficient of x is here a. So these two must be equal, otherwise it is not forms a irrotation vector. That means a is equal to 1. Next one, come to the here z. So z, z, the coefficient of z in this one 2. Next one, come to the coefficient of x here 2. So here the c is equal to 2. Similarly, come to the here the bz. The coefficient of z is here b in this one, and the coefficient of y here check, because it is the y term and it is the z term. So just to interchange. Now the b is equal to 3. If b is equal to 3 and c is equal to 2 and a is equal to 1, this must be the irrotational vector. Okay? Next one, come to the this is the I am giving the proof. Just to a and b both are irrotational vector. Just to show that this a cross b is the solenoid. That means this one I can write in another way also, in the symbolically. So assume if del cross a 0 and del cross b 0, then prove that del dot a cross b 0. Okay, this is the question. So the same question I can write like this also. Okay, del cross a 0 and del cross b 0, you have to prove that del dot a cross b 0. Okay, so this a and b both are irrotational, and a cross b we have to prove that solenoid. So this is the 8th problem in the previous class. Next one, come to the 9th one. So in the 9th one, same. So this 9th, this is the vector, and this vector always a solenoid vector, but here the condition is a plus b plus c must be 0. If a plus b plus 0, this f must be the solenoid vector. Next one, I think this problem already we have seen. Yzi plus xzj plus xyk. This is always irrotation vector. Not only irrotation vector, but also it is the solenoid vector also. Now come to the 11th problem. So 11th problem is just a small modification, just a combination of 9th and 10th problem. Okay, in the 10th problem just I am taking the yz and xz and xy. Just I am adding here ax, here the by plus cz. Now come to the in the 9th problem. In the 9th problem here I am taking ax, here the by and cz. If the a plus b plus c, this vector is solenoid vector, and for any abc this vector is the irrotational vector. Okay, am I clear? Okay Nandi. So this is the brief. Hello. So this is the review of the previous class. Now come to the today class. ఒక్క నిమిషం అండి.